Hello, I'm going to talk about Boyle's Law today. This was made and created by Robert Boyle, hence the name Boyle's Law. And Boyle's Law stated that the volume of a given amount of gas held at a constant temperature varies inversely with the pressure. This part is very important because it gives the basis for the equation. As you can see here, I apologize for the sloppiness, but as you can see here, we have 3 liters of a liquid, and we have 2 atmospheres. We multiply those two together to get 6 liters over ATM. 3 liters is volume 1, and 2 ATM or atmospheres is pressure 1. This is the first part of the equation. Next part is over here. We have 6 liters of a given liquid, and we have 1 atmosphere. This is our volume 2 and our pressure 2. And if you multiply those two together, you get 6 liters over ATM. As you can see, these two both are the same, which proves Boyle's Law is true. Let's talk about the relationship between pressure and volume. As the pressure goes up, the volume goes down. As the pressure goes down, the volume goes up. This graph right here, for the people that learn better with visual images, shows exactly the relationship between pressure and volume. And as a side note, when you're solving equations, to make sure you have the right answer, use this. If you see that the pressure, the given pressures go up, you'll know that your answer or volume will be lower than the initial volume. And if you're solving for something else, say if you have 1 pressure and 2 volumes, you'll know that the second pressure will be down, or up, because the pressure will be down. Right. Let's do some problems. Alright. At 1.70 atmospheres, a sample of gas takes up 4.25 liters. The pressure on the gas is increased to 2.40 atmospheres. What will the new volume be? Let's take a moment and identify our pressure 1, volume 1, and our pressure 2. These 3 are going to be the main variables for our equation. Alright, set up the equation. Equals volume 2, pressure 2. Let's plug in. Alright, we have all our variables and numbers plugged in. Let's go ahead and solve. If you multiply these two together, 1.70 and 4.25, you will get 7.22 equals 2.40 volume 2. So weird looking parentheses. Anyway, I'm going to isolate the variable, or what we're solving for, which is volume 2. So we're going to want to divide by 2.40, basic algebra. And then you'll end up with the answer 3.01 atmospheres. Or no, I'm sorry. liters. Okay. Right. Next problem. A 6.5 liter tank of methane gas has compressed gas in it. So the pressure is 2,500 kilopascals. What will the pressure of the gas be if the gas is put into a 3.25 liter tank? Let's write down what we have. So, we have our volume 1, which is 6.5. We have our pressure 1, which is 2,500. And we have our volume 2, which is 3.25. Alrighty then. Solve for the pressure. So once again, write down our equation. Equals pressure 2. Alright. Let's plug in everything. 6.5 2,500 equals 3.25 P2. Alright. Plug and solve. Let's go. 2,500 times 6.5 equals 16,000 equals 3.25. Once again, we isolate the variable and we get 5,000 kilopascals. And that's it. I hope this lesson helped, and this lesson tutorial helped, and see you later.